Welcome everyone, and thank you for joining us. Please enter your questions for the presenters in the questions panel of your GoToWebinar control window. And at the end of the presentation, we will get to them in the order received. This session will be recorded and the slides will be available on our website shortly after the webinar concludes. Now I'll pass it over to our presenters, Floyd Smith, Director of Content Marketing at NGINX, and Faisal Memon, Product Marketing Manager at NGINX.
Hello, this is Floyd Smith, and this webinar is NGINX, Basics and Best Practices. And the presenters today are Faisal Memon and Floyd Smith, and we are getting started. There we go. I'm the Director of Content Marketing at NGINX, and I was formerly with Apple, AltaVista, and some companies that don't start with an A, and I've written a number of technology books. My colleague Faisal is Product Marketing Manager here at NGINX, and he was formerly with Riverbed and Cisco. Our agenda today is that I will introduce NGINX, the product and the company, and then switch over to Faisal, who will talk about installing NGINX and NGINX Plus, key files, commands and directories, basic and advanced configurations, logging and monitoring, and a summary. At the end, we'll have a little time for Q&A, but there's a lot of content here. This is a very popular topic for us. People are learning NGINX all the time, and many people learn by hearsay from each other or by experimenting things they pick up from blog posts, ours and others, our documentation. So there's always a lot to learn about how to really get the most out of NGINX and NGINX Plus. We've also just introduced our new product, NGINX Controller. We won't be discussing that today, but that's an alternative for some of the monitoring and management tasks. So how did this all start? Igor Sisoyev says, I wanted people to use it, meaning NGINX, so I made it open source. That's been very successful. The care and rigor that Igor and the engineering team have devoted to NGINX, developing, maintaining, and supporting it over the years have been so impressive. Today, 336 million total sites run on NGINX, and that's something like 40% of the internet. And that is actually skewed toward the busier sites. 64% of the busiest 10,000 sites run on NGINX. Now, why is that? Busy people with busy sites are busy. Why would they switch? As a site gets bigger, why would you consider switching to a different web server? I'll explain a little bit about that now, but you can see here that when the blue bar, top 10,000 websites, we have 64% of the of websites running on NGINX. Our customers include Deloitte, McDonald's, US Bank, Zendesk, Microsoft, and a whole host of others. We're very proud of them. We recently had a meeting of our customer advisory board and got to hear in depth from half a dozen of our customers about their experience with NGINX, and it was really a rewarding thing to take part of. And so why has NGINX spread so widely? There's really two different use cases for NGINX. And a lot of people who use NGINX don't really understand exactly how all of this works. So I'll explain it briefly. NGINX works both as a web server and as a reverse proxy server, load balancer, cache, and much more. As a web server, NGINX solves the C10K problem, meaning it can handle more than 10,000 simultaneous connections at a time. That means that it's very high capacity. It doesn't slow down hardly at all as you add thousands and thousands of concurrent connections. And that's in contrast to other web servers, which devote a lot of memory to each session and so tend to bog down and then even crash as you add users, which is an awful experience. You know, someone mentions your site in the New York Times and suddenly it's crashing left and right. So you can switch to NGINX as a web server, or if you either don't want to change your stack or are already using NGINX but need more capacity, you can put NGINX in front as a reverse proxy server. Now, just that step gets you a lot of benefits because you've put the traffic management on one server and the application management on another server or set of servers. Then that load balancer, with a lot of hard work, can serve as a content cache, do SSL termination, rate limiting, basic authentication, all sorts of functionality, and load balancing, of course, as well. NGINX Plus adds advanced features around load balancing, cache purging, high availability, and others. So that's our commercial product. NGINX open source, of course, is available free, and NGINX Plus is not. NGINX as a company is the creators of NGINX Plus, and we're the ones who sell and maintain it. Although much more than half of our engineering effort goes into the into the open source product. So NGINX Plus was first released in 2013. We've gotten several rounds of funding, which you can find on Crunchbase, and the Series C round was just closed, and that's $43 million from Goldman Sachs and NEA, who were our biggest original investors in earlier rounds. We have offices in San Francisco, London, Cork, Singapore, Sydney, and Moscow, plus a few standalone offices, smaller offices in other places to serve a wide range of our 1,500 plus commercial customers and host our 200 plus employees. But headquarters is here in San Francisco. All right, I'm going to turn it over to Faisal to talk about installing NGINX and NGINX Plus.
All right, thanks, Floyd. And I'm Faisal Memon, and I will be taking you guys through the remainder of this webinar. I'm just going to jump right in because we've got a lot of stuff to cover. And so NGINX, just like any other open source project, there's a number of different ways it can be installed. You can, of course, compile from source, but if you want to just install a pre-built binary, which is a lot easier, you have two basic options. You can install from our official repo, or you can install from the repo that is built into your operating system, so the Red Hat or Debian or Ubuntu repos. And of the two, we typically recommend people to use our official repo, and that's just because we actively develop on our official branch or official repo, so that means you're getting the latest security enhancements, features, and whatnot. If you're using a third-party repo, you can be using older software. Debian Stretch, for example, which is the newer OS in general, still has a fairly old version of NGINX, version 1.10.3 last I checked, which was released in January 30th, 2017, so about a year and a half ago. So you're running older code in a lot of cases if you're using a OS vendor repo. Within our official repo, we have two branches. We have a mainline branch and a stable branch. The mainline branch is the one that we actively developed, so that's where all the new feature enhancements go. That's the branch that we have QA test, and that's the one that we look at the most. It's also the branch that our NGINX Plus builds are based off of. We also have a stable branch, and the stable branch is great for users that don't want the newest features and enhancements, just want something that's stable, doesn't change very often, and is only patched when something critical or a security vulnerability arises. But that's what you're looking for. Our stable branch is a good match there. Of the two, we still recommend people to use the mainline branch just because that is the one that we work on the most and the one that has most eyes on it. So between the two, we typically recommend people to use our mainline branch. So next, I'm going to step through installation instructions. I'm going to start off with the Debian and Ubuntu flavor of Linux. The next slide will cover Red Hat and CentOS, so if you're into those operating systems, don't worry. We'll get to that in just a minute. But if you're on the Debian and Ubuntu side, to use our official repo, you're going to first make a new file called nginx.list under etc app sources.list.d and paste in these two lines that I have here, and you'll get the slides afterwards, so you can just copy and paste them. And I'll also give you a link to our official installation instructions on nginx.org. But you're going to go ahead and paste in these two lines into that file. You can also just paste them into just the sources.list file directly, though I don't recommend that. I think it's nicer to have all third-party, and third-party I mean from the reference of the operating system, so not all non-operating system vendor repos in their own file in the sources.list folder. So you can put nginx in the nginx.list file, and if you're using Docker, for example, you can create a docker.list and put the Docker stuff in there. So it's a nice way of keeping things organized if you have a separate file per repo. So after you paste in these two lines, you're going to have to make some changes. And looking at the URL here, first off is that we're using our mainline branch here. So if you want to use the stable branch, you're going to change mainline to stable. Next thing is at the end of the URL, it says OS. So you're going to change OS to either Ubuntu or Debian, depending on which one you're using. And then the next thing that you're going to change is code name. And you're going to change that to either Jesse or Stretch if you're using Debian. Those are the two versions of Debian we support. We no longer support Debian Wheezy. And if you're using Ubuntu, you're going to put it either Trusty, Xenial, Artful, or the latest version of Ubuntu 18.04 called Bionic. So those are the 4 versions of Ubuntu we support. And Trusty, I believe, is fairly old, it's 14.04. So you can still run a fairly old version of Ubuntu and be okay. So once you enter that into the file, you're going to go ahead and save it. And the next thing you're going to do is, covered in the bottom gray box, we're going to get the nginx signing key. So you're just going to use wget to get that. And then do app key add nginx_signing.key. And that'll add in the nginx signing key so that you can access our repo. Next thing you want to do is an apt-get update, and that's going to download information from our repository. And once that's done, you're going to do an apt-get install nginx. In this box, I have the -y flag, which just bypasses apt-get asking you to install it. So you just do an apt-get install -y. It's an automatable, scriptable way of doing apt-get. And the last line starts up nginx running at the current time. So what I see a lot of times is when I install nginx, it doesn't automatically start. So you just do an etc init nginx start, and that'll start the nginx process. If you reboot the server, what I've noticed is that even though it doesn't start right away, on reboot it'll start. So you can also just reboot the server if you want. But in any case, it won't hurt to run this command even if the binary process has started. All right, moving on to CentOS and Red Hat. If you're into those operating systems, the instructions are fairly identical. You're going to create an nginx.repo file under etc yum.repos.d. And you're going to paste in the contents in the top gray box with some changes. And the changes are going to be, you're going to put in rel or CentOS in place of OS, depending on which one you're using. And for OS release, you're going to change that to 6 or 7 if you're using the 6 or 7 versions of CentOS. We no longer support the 5.x versions of CentOS and Red Hat. The $base arch stays the same, so that's not something that's modified. Next thing we're going to do is the -y install nginx. And that's going to install the nginx binary along with any dependencies. And the next 2 commands enable nginx to be restarted on boot, as well as to start nginx process right now. And so and I forget which one is which, but you just run both of them just to be safe. So system control enable nginx, system control start nginx. At that point, nginx process should be running, and then nginx will also automatically start on reboot. Next 2 commands are to punch a hole in the firewall. CentOS and Red Hat are built with firewalls by default, and the firewall blocks all incoming connections. So you're going to have to punch a hole in that firewall, at least for port 80 for initial testing. And so the way you do that is just do firewall-command -permanent, which makes the changes permanent so that it is sticky across reloads and reboots and whatnot. You're going to say that it's in the public zone, and we're going to do -add-port 80/TCP, and then enter to enter that command. And then going forward, of course, you can add in port 443 or whatever other ports that you want to open up and have nginx proxy for you. Once you open up that port, you're going to do a firewall command --reload, and that's going to bring in the new configuration. And from this point on, port 80 should be opened up. For Nginx Plus users, you're going to go to cs.nginx.com/repo_setup and select your operating system from the drop-down list. The instructions are very, very similar to the OS open source installation. And the only major difference is that you're going to use a different repo because our Nginx Plus is hosted in a different repo than our open source software. And we use a client certificate to protect that repo. So when you sign up for an Nginx Plus subscription or a free trial, you're going to get a client certificate. And so you're going to make sure to have that available before accessing our official repo. So once it's installed, how do you verify that Nginx is running correctly? A couple commands that I run. One is nginx-v, which just prints out the Nginx version and exits. So if the nginx-v is successful, then you know the binary has been installed properly. 1.15.0 is the latest version of Nginx as of the recording of this webinar. Next thing I usually do is a ps-ef pipe grep nginx, and what we're going to see is two processes running, at least two. One is the nginx master process, and there's always going to be one version of the nginx master process running per server. The next is a worker process, which does all the heavy lifting of handling user requests. And there can be multiple worker processes running, but there should be at least one. And we'll come back to the worker processes a little bit later on in this presentation. But as long as you see one master process and at least one worker process running, then you know nginx is running and has been installed properly. The last thing we're going to do to verify installation is just go to the IP address or host name of our server in a web browser that's on the same network as our nginx server, the server that we installed nginx on. And if we do that, we should see the Welcome to nginx page pop up. And so if you do see Welcome to nginx, then you know for sure that you have successfully and properly installed nginx. If you don't see the Welcome to nginx page, there's a number of different things that can go wrong. So I just recommend to go back through the installation instructions and make sure that all the commands have been executed. If you're on the CentOS side, make sure that the firewall is allowing port 80 through. And so step through all those instructions, ensure that you have stepped through everything. And a few more things on installation before we go on to the next section. For full installation details, go to nginx.org/en/linux_packages.html, and that lists all of our supported distros and CPUs. It also has SUSE Linux installation instructions if you're into SUSE Linux. On the Nginx Plus side, go to cs.nginx.com/repo_setup. And that also lists all the supported distros and CPUs. Nginx, both open source and Plus, support ARM CPUs as well as PowerPC, so you can go through those respective pages to see what operating systems that we support those CPUs and what all operating systems that are supported. All right, so now that we've installed Nginx, let's take a tour through all the files, commands, and directories that are important to know as you use Nginx. And the directory that you're going to be using probably the most frequently as you move on into using Nginx is the etc nginx folder. And that's where all Nginx configuration is stored. Within this folder, you'll see a number of files, and a key file in this directory is going to be nginx.conf. And you typically don't need to modify this file. And a little bit later on in the advanced configuration section of this presentation, we'll go through some changes that you can make in the nginx.conf file to improve performance, but for the most part, you're not going to be touching this file. If you look into this file, under the HTTP block, you'll see an include conf.d/star.conf, which is going to include the configuration stored in the conf.d folder, and it's going to take in any file with the .conf extension. And so the .conf files are where you're going to put all of your Nginx configuration. So that's where the virtual servers, the pools, and all these configuration syntax is going to live. You typically create a file per virtual server and just have it in a .conf extension, and that's on the right side over here of this slide. I typically will name the files, for example, www.example.com.conf, www.example2.com.conf, so you're just going to name it with the host name of the site, .conf. That's the practice I follow, but you can, of course, do whatever makes sense to you. The next important directory is going to be var log nginx, and that's where all the nginx logs are stored, including the error log and the access log. And we'll come back to logging towards the end of this webinar. So some key commands for nginx one is nginx -h, and that's going to display the nginx help menu. So that's always a good thing to go to if you're looking for how to use the nginx binary. Nginx -h displays all the options. Command that I use very often is nginx -t, and so anytime you're making nginx configuration changes, first thing that you want to do after saving the files and making those configuration changes in nginx -t, which is going to check your nginx configuration syntax, make sure it's okay, and if it's not okay, of course, it's going to print out the file or line number in the file to look at where there's a syntax error. So if you've ever used a compiler before, it functions very, very similarly. It's just going to compile your configuration and tell you if there's any errors. Next most commonly used command for me is nginx -s reload. And so after every configuration change, if you want that configuration change to take effect, you have to do an nginx -s reload. And that reloads the nginx processes. This is a graceful operation, so any connections, any actual user traffic that's going through will not be disturbed. So it is a graceful way of restarting NGINX and reloading in new configuration. You can do an NGINX minus capital V. That's very similar to the NGINX minus V that we used earlier, which printed out the NGINX version. If you put a capital V, it prints out the version along with some more information on how this NGINX binary was compiled, what modules are included, what compile options, OpenSSL version it was linked to. So a lot of useful information that comes in handy for debugging, or if you're asking someone for help, either us or Stack Overflow or wherever it is you go for help. NGINX minus V is a very, very useful command to have. The last useful command is NGINX minus capital T, and that's going to dump your full NGINX configuration. So on the previous slide, we talked about how we want to split the configuration and have a separate file per virtual server. So if you're seeking help from our support or from third-party sources, a lot of times, at least the first things that we'll ask for is, give us your full NGINX configuration. So if you do NGINX minus T, they'll just dump out all your full NGINX configuration, so you don't have to go and concatenate all these files or send us a bunch of files. If you just do an NGINX minus T, you'll just get a dump of your entire NGINX configuration. So that's very useful for seeking help and getting support. All right, so those are the key files, commands, and directories with NGINX. Next thing we're going to move to is some basic configurations with NGINX. And the most simple configuration with NGINX I can think of is this virtual server here. And the virtual server is what defines the IP address and port that NGINX listens to. And in this case, what we're doing is we're going to listen on port 80 and for anything on www.example.com. So that's the host name that we're going to be monitoring. And for any request to www.example.com, we're going to return a 200. And so that just means, okay, so very simple, just user sends a request, NGINX is going to reply directly with the 200. So probably the most simple way you can configure NGINX. A good way just to test NGINX and make sure that everything is working and understanding the concept of the virtual server and some of the basic directives within NGINX. So stepping through all of these directives here in this gray box, starting from the top is the server directive, and that defines the context for a virtual server, and then you put the curly braces around it, and that defines the context, or everything within those curly braces is going to be within the context of this virtual server. The first important directive within the virtual server is a listen directive, and that specifies the IP and port NGINX should listen on. So if you see here, I haven't actually specified the IP address, and so what that means is that NGINX is going to listen to all IP addresses that the underlying Linux operating system is listening to. So we're going to bind on all those IP addresses. If you want to bind on a specific IP address, you would just list the IP address there in IP:port format. So you would have IP address, whatever it is, :80, and NGINX will only listen on that IP address and not on all the other IP addresses that the system is listening to. If you're coming in from the world of F5 or hardware load balancers, those products typically ask you to define a unique IP address per virtual server. With NGINX, you don't need to do that. And we're going to come back a little bit later on to how you can multiplex multiple sites and multiple host names, multiple domains on a single IP and port pair. So you don't need to have an IP address per virtual server. NGINX does not manage IP addresses for you. We just use the IP addresses that the underlying Linux operating system has already binded to. So we just rely on Linux to do the networking and IP address and ports for us. Next important directive here is the server name directive, and that specifies the host name of the virtual server. And I'm going to come back to the server name directive a little bit later and how that is used to multiplex multiple sites on a single IP port pair. The server name directive is optional, but it is a best practice to always explicitly define the host name that you want this virtual server to listen on. The next directive is the return directive here, which just tells NGINX to return a 200. Other things that you can do are return 301 if you want to do a redirect, various different things. In this case, just to make things very simple, we're just doing a return 200. Okay, moving forward to a slightly more complex configuration. Here, instead of just returning a 200, we're going to have NGINX serve static content for us. So I call this the static content configuration, or what's commonly referred to as just the web server configuration or the web server use case with NGINX. So you can see here that the first two directives within the virtual server are the same. So we still have the listen server name just as before. And throughout the rest of this presentation, a lot of times I'll just leave out the listen and server names to save space, but just assume that those are always there. The next thing we have is a location. So we're saying any URI with /i in it. We're going to do the following configuration commands within the curly braces. And again, with the location blocks, we're going to come back to that a little bit later. So I'm just kind of putting this out there, but we're going to see how location blocks come into play a little bit later. So just for now, don't pay too much attention to it. The most important directives here are going to be the root, alias, and index directives. So root directive specifies where your files are stored on the local file system. Alias is a slightly different version of root, which specifies where the files are, but also specifies a replacement for the specified location. So how does that differ? We'll get to that just a little bit. But the last thing I want to mention is the index directive. And so the index directive defines files that will be used as the index. So if the user just requests, in this case, www.example.com without specifying a file, then the index directive will come into play. And in this case, NGINX will try to find index.html. And if index.html is not found, then it'll try to find index.htm. And if not, then it'll return an error. So how does this work in the actual context of user requests? So now here I'm on the 3 bullet points at the bottom of the slide. So if the user requests www.example.com, as I mentioned, NGINX is going to then return user share nginx HTML / index.html as specified by a combination of the root directives and the index directives. If we're using the root directive, and the user requests www.example.com /i /file.txt, NGINX is then going to search the file system for user share nginx HTML /i /file.txt. So you see that it's just pasting the entire URI onto the end of what's in the root directives. The alias directive I have commented out, but if the alias directive was not commented out, you typically won't use both root and alias, so you'll just use one. So let's say the user requests that same file. So instead of searching for /i /file.txt, what we're going to do is get rid of the I portion and just take the file. So the alias, if you're using alias, that means that we're going to ignore the actual URI, just take the actual name of the file, append that to the end of the configuration value for alias, and then search the file system for that. So the root and alias are very, very similar, very subtle differences. What I see, I think, and what I use more often is root. But a lot of cases you might want to just strip off that URI, and if you do, then the alias directive is perfect for you. Okay, so that is how you configure NGINX to serve static files. Moving up in complexity now, let's talk about how to use NGINX as your load balancer. And so, very common concept in load balancing, especially if you're coming from the world of F5 or Citrix NetScaler, is the concept of the pool. And the pool defines all the backend servers that you're going to be using and the servers that NGINX is going to be load balancing to. So in the world of NGINX, we call the load balancing pool the upstream, and we define those servers using the upstream directive. And so we have that in the top of this gray box here. We have the upstream, and then the name of the upstream group, and that name will come in handy, of course, in just a little bit. And then we have our context for upstream, and then within the upstream block, we define all of our servers that we're going to be using. So we just go server, and then the IP and host name of the server that we want to load balance to. In this case, we have 2 servers, server1.example.com and server2.example.com. The next thing you define then is your load balancing algorithm. If you don't define a load balancing algorithm, by default, NGINX will do round robin load balancing, which may be okay for you. But there's a couple different more intelligent load balancing algorithms that you can use. One is called least connections, and you specify that using a least_con within the upstream directive. And that will instruct NGINX to select the server with the least amount of active connections. So a slightly more intelligent way of load balancing than round robin. An even better load balancing algorithm is least time, which is what we've depicted in the gray box in our configuration sample here. And so least time will also favor servers with the least amount of active connections, but it'll also factor in server response time. So if a server doesn't have a lot of connections, but it's bogged down or it's slower, NGINX will favor that server less than servers that are responding quicker. So it's a factor of both connection count as well as response time. So this will come in handy, for example, if you have a heterogeneous server farm and you have some servers that are faster and some servers that are slower, the response time will then come into effect because the slower servers will respond slower because they'll get bogged down with load much quicker. Another nice use case for least time is if all your servers are not located within the same data center. If you have some sort of bursting data center or you have an alternate data center and you just want to burst traffic to that data center when your main data center is filled up, the least time comes in handy there because the network latency will cause the response time to increase. And so having a larger response time means that with the least time algorithm, NGINX will favor the remote servers less and will favor the closer servers more. So it's a good way if you have servers that are not all located within the same data center. Least time load balancing is exclusive to NGINX Plus. Moving down a little bit in the configuration syntax, we see the proxy pass directive. And so the proxy pass directive is what links the virtual server to the pool. So in this case, we have proxy pass http://my_upstream. So what is going to happen here is that any requests that go into this virtual server will then be load balanced to all the servers in the my_upstream group or load balancing pool. So that is how we link the virtual server to the pool. You see here I have http:// in front of it. You can also do https:// if you want communication between NGINX and your upstream servers to be encrypted. By default, NGINX will rewrite a host header to the name and port of the proxied server. So in this case, if we're proxying to server1.example.com, instead of the host header having the original value, www.example.com, it's going to be overwritten with server1.example.com. And if that's not what you expect, in a lot of cases, what you want is to actually pass in the original host header. You can use proxy set header host and then $host, and $host is an NGINX variable that hosts or holds the original client host header. NGINX has a number of variables that hold a lot of information about the connection and the user request. If you just do Google search for NGINX variables, you'll have a full list of all the NGINX variables. So $host is one of them, and that holds the original host header. When I first started using NGINX, I wasted a lot of time on why is stuff not working, and it turned out to be that I wasn't using this proxy set header host $host command. So if stuff is not working for you and you just get started, you might be missing that proxy set header command. So that's something to look into. All right, next up is a reverse proxy configuration. So you can use NGINX to serve static content. We covered that on the slide before the last slide. You can also use NGINX to reverse proxy your dynamic content. So this is slightly different than if you're coming from the world of Apache. If you're using Apache HTTP server, Apache will serve static content and run the dynamic content directly for you. NGINX will not run dynamic content directly. Instead, we rely on an application server to do that for us. And for PHP, as what we're using in this example, it's called PHP FPM. FPM is a very, very lightweight application server, and most people that run NGINX with PHP are using PHP FPM. And it works really well. It's super lightweight. It's also just available to install, so you just do an apt-get install -y. In this case, PHP 7.0-FPM. PHP 7 is the latest version of PHP and offers the best performance. You can also use PHP 5. The key directive to pay attention to here is the fast CGI_pass. If you remember on the previous slide, we had proxy_pass. In this case now, instead of proxy pass, we're using fast CGI pass. And you'll notice with NGINX, we keep a lot of the configuration syntax similar across different paradigms. So the fast CGI pass function is very similar to proxy pass and just defines the servers we want to proxy to. There's two ways to fast CGI pass that come in to play. One is the one that I've commented out in this configuration syntax, is just using localhost 127.0.0.1:9000. 9000 is the port that PHP FPM listens on by default. Slightly better way of doing it, in my opinion, is to use a Linux file socket. And so that will require some configuration on PHP FPM. So that's just something you need to look into, but it's not difficult or anything. But using a Unix socket instead of the networking layer, I think improves performance a little bit. I haven't done any testing to verify that, but I think just thinking about it logically, instead of going to the networking layer, you're just using a file socket directly, you're going to get better performance. So if you're using NGINX with fast CGI with PHP or even UWSGI or anything like that, make sure that you are using a socket. NGINX can also be your content cache. So if you're using a CDN today, more likely than not, that CDN is basically just NGINX open source under the hood with the UI and some other value add on top of it. So if you look at Static Path, Cloudflare, or even Netflix's custom CDN that they use to serve static content, all of those CDNs are basically just NGINX under the hood. So NGINX is a very, very powerful content cache, very high performance, works really, really well. So if you're looking to do content caching within your application, definitely consider NGINX content caching. There's two key directives here to setting up NGINX content caching. One is the proxy cache path. The other is proxy cache. Proxy cache path, it sets up all the parameters for caching. And then proxy cache is what instantiates the cache or enables it for a particular context. So looking at the proxy cache path directive up at the top, first thing that we're going to specify is the location of the file system where we want the cache to go. A lot of people just use /temp, but that can be a little dangerous because /temp is kind of a free-for-all. So you might want to use something that's a little bit more managed and maintained, like /opt, /var, /etc nginx. So there's a lot of different places where you can put the cache. So that's really up to you. The next important directive is levels equals 1.2. That means to use this two deep file structure. So there'll be directories and then files within the directories for how to organize the cache rather than just dumping everything into a single directory. So I've always configured it with levels equals 1:2, and that's typically what you want to do. Next up is we're going to define the size of memory to store cache keys. So this is like the size of shared memory that we're going to use. You do that with the key zone parameter, and a 1 megabyte zone can store data for about 8,000 keys. So you want to make sure that this memory zone is big enough to store all of the cache keys that you're going to need, or more generally, how many elements, how many objects that you want to cache. So you want the zone here to be big enough for that. So in this case, I've defined a 10 megabyte zone, so that means 80,000 keys or 80,000 objects that I can cache. We can also define the max size of the cache. It's optional to do that, but it's nice to set an upper limit so that the cache size doesn't just grow and take up your entire file system. Next up is inactive, and that defines how long an object can stay in the cache without being accessed. So if an object in this example here is in the cache for more than 60 minutes, but no one accesses it, NGINX is going to prune the cache and delete that object out of the cache to save space. By default, it's at 10 minutes, which might be a little too aggressive. So that's something that you want to play with, and is definitely going to be something that's unique to your application and your use case. Next up is use temp path equals off. So that's something that you always want to do. Otherwise, you're going to have to specify a folder to store temporary files for caching in. So if you just use temp path off, it'll just use the standard cache directory that you've already specified. And then, of course, we have the proxy cache directive using my_cache, which we defined earlier under proxy cache path, and that's what's going to instantiate the cache in this example for all locations under the root directory. NGINX is very commonly used for SSL termination. And so in this configuration, what we're doing is we're taking in all clear text traffic, and that's the top virtual server here. So we're listening to port 80, and we're just returning a 301 to the HTTPS site, same exact host name, same exact URI. So we're just forcibly pushing everyone to SSL. It's always good practice to do that. It's non-mandatory, of course, but it is definitely becoming much more industry standard to SSL encrypt everything. And Google, of course, will give you better search rankings if your site is all SSL encrypted. So it's much better for SEO and just general better security practices to SSL encrypt everything. Some differences from an SSL encrypted virtual server versus non-SSL is that one is the port's going to change. So we're going to use port 443, the standard port for SSL. And then we have an SSL parameter on the listen directive, which instructs NGINX that this virtual server is SSL encrypted. And if looking down, we have two directives here that define both the public cert and the private key to use with the SSL certificate and SSL certificate key directives respectively. Otherwise, all the configuration is the same for SSL versus non-SSL. If you're looking to where to get certificates from, Let's Encrypt is a good source of free SSL certificates, fully automated. And this blog here talks about how you can use NGINX with Let's Encrypt, and the slides, like I said, will be available afterwards, so you can just look at the slides and go to that URL, or just search Let's Encrypt NGINX on our website, and you should be able to find our blog on how to use Let's Encrypt with NGINX. Works really well, fully automated. The blog even goes through how to set up a cron so that the certificates are automatically renewed every 90 days, so you don't have to worry about it, and it's all free. So definitely something to look into if you're using SSL. HTTP2 was released semi-recently in 2015, I believe. So HTTP2 can improve the performance of your site with little to no backend changes, so it's really nice for that. And so to enable HTTP2, all you do is just add HTTP2 to an existing listen directive. HTTP2 is only supported with SSL in all browsers, so you want to make sure that it's on an SSL-enabled virtual server that you do this. NGINX only does HTTP2 client side. Server side is always going to be HTTP 1.0 or 1.1, depending on your configuration. And gRPC is a special case, which we'll come back to shortly. And just to note, HTTP2 requires OpenSSL 1.0.2 or later to work properly. So that means you're going to have to run Ubuntu 16.04 and later, Debian 9 stretch or later, and Red Hat 7.4, CentOS 7.4 and later. So any of those operating systems, more specifically those operating system versions, if you're running those, then you can use HTTP2. If you're using earlier versions of them, HTTP2 will not work properly. Okay, so I mentioned this actually on the very first virtual server slide on multiplexing multiple sites on one IP. And so this is really useful if you're coming in from the F5 world and you're wondering, where do I configure the IP addresses and how do I handle multiple sites on a single server? We do that using a combination of the server name directive. And so what you're going to do if you want to multiplex multiple sites is you have multiple virtual servers, and each server is going to have a unique server name for the name of the site. So in this case, I have three, example.com, example2.com, and example3.com, right? So now I can handle traffic for all three of those sites. And depending on what the host header says is what virtual server NGINX is going to select. If you notice at the very top, I have a default server, and I had the default server configured on a lot of the previous slides, but I didn't mention it. So the default server comes in handy in this use case to answer the question of what virtual server should NGINX use if the host name, the host header coming from the client is empty or doesn't match any of the existing server names that we've configured. NGINX will then use the default server for that. So it's important to have a default server configured, so that's kind of the catch-all of if it doesn't match any of these other virtual servers, NGINX will select the default server to use for that particular request. And that's how you configure multiplexing. So like I said before, you don't need to have an IP address configured per virtual server. You're just going to use the server name directive and the host header to multiplex multiple sites on a single IP and port pair. And so coming back to the location blocks, I used those in previous slides, but I told you to kind of not pay too much attention to them. So where location blocks come in handy, and they're a very, very powerful directive within NGINX, is to do layer 7 request routing. So we have here a single virtual server, and within that single virtual server, we can take different actions depending on what the ERI is, and we configure that with a location block. So in this case, we have, let's say, a microservices architecture, and we have 3 backing services. I can have NGINX select a different upstream pool to use depending on whether the URI says service 1, service 2, or service 3. And it's not just that you select a different pool, you can just do custom action. So I can even have a service 4 here where NGINX just responds directly with a 200, or I can just do all kinds of different things. I can have service 2 be cached, but not service 1. So the location blocks are your way to really cut up the URL and do custom actions based on what's in the URL. You can also do regex matching within location blocks. You can do very complex matching of the URI and do custom actions and even pull out portions of the URI and do rewrites. And there's a lot of different things you can do with location blocks. And I've really just scratched the surface of it with this presentation. So if you just look at our documentation on nginx.org on location blocks, you'll see the full power of it. So it's definitely something to look into as you begin your journey with nginx is location blocks. All right, so that covers the basic configurations of nginx. Let's do some advanced configurations before we jump into logging and monitoring and summary. So I'm going to step through a little quickly for this because we are running short on time. But I brought up the nginx.conf file earlier and said that you don't need to modify it typically. So there's some modification that you do want to make to it is really just this top one here of worker processes. So you want to set worker processes to auto. And I've seen this sometimes be set to auto, sometimes one, and I haven't been able to figure out what what the formula is when it's set to auto and when it's not set to auto. But when you're actually deploying in a production environment or even in your testing environment, you do want to make sure that your worker process is set to auto. And what auto means is that nginx will create one worker process per core in your system. And that is what's recommended for most deployments to get the maximum performance from nginx is to run one process per core. And so you do that with worker processes auto. Next thing we have configured here is some stuff around Keepalive. So by default, nginx will time out all idle Keepalive connections after 75 seconds. If you want to keep Keepalive connections open longer, if you have bursty clients or you have a client that's going to be idle for longer than 75 seconds and you know that, you can increase that timer here. And Keepalive requests also after a certain amount of requests. And I didn't put the default in this slide, but there is a default value for this. And after that, nginx will close off the connection. So if you want connections to stay open for more requests, then you're going to override that with the Keepalive request directive. You can also set this per virtual server. So you can have a global setting here and then override it per virtual server, or you can not even do it in nginx.conf and have these Keepalive settings per virtual server. It's entirely up to you. The next important thing that I think will improve performance actually is to upgrade to HTTP 1.1 on the backend side, so nginx talking to your backend servers. By default, nginx uses HTTP 1.0 with connection closed, so it'll just create a new connection per request and then close that off after the request. So it's fairly inefficient, but we do it that way just to maintain maximum compatibility. If you have an older application, for example, that only uses HTTP 1.0, nginx will work with that out of the box. But for most cases, what you're going to want to do is well, first I'll specify Keepalive here on your upstream group, which is going to enable a TCP connection cast. In this case, we're going to have 32 TCP connections open. And then we're going to upgrade the connection to 1.1 using proxy HTTP version. And then we're going to clear the connection header, connection close out by using proxy set header. So now once we've done that, now we have Keepalive connections to Upstreams or your load balancing pool if you're coming from the F5 world. So that will improve performance for you. SSL Session Caching is a good way to improve your SSL performance. And 1 megabyte session cache will store for about 4,000 sessions. So you're going to want to look at how many SSL sessions you typically have going at any point in time, and then increase the size of your SSL session cache equally. And the cache is shared across all nginx workers. So SSL Session Caching can improve performance so that clients, if they are idle for a while but come back, you don't need to redo all of the SSL and RSA calculations, which can be fairly computationally expensive. Those can be reused if you use the SSL session cache. Some advanced caching configuration here. And I'm just going to focus on the proxy cache background update, proxy cache use stale directives here. And so using those two in concert, what you can configure nginx to do is, for example, let's say I have large video files or just large files in general, and the cache timeline, the expires header on that particular file is expired, but a user requests it, rather than having that user wait while nginx goes back to the origin server and refills that file, especially if it's a video file that's a couple gigabytes in size, and that operation can take some time. So what you can have nginx do instead is just give that stale version of it to the user and then refill in the background. And so by using proxy cache use stale updating combined with proxy cache background update on, you can accomplish that. I mentioned gRPC earlier. So gRPC is a special case where we do some form of HTTP2 to the upstream server, just we just do enough HTTP2 to support gRPC. gRPC, if you're not familiar with it, is mandatory HTTP2. So to configure gRPC, and it requires HTTP2 end-to-end. So that's very important with gRPC. So to configure gRPC with NGINX, you're gonna have to first use a HTTP2 enabled virtual server. And in this case, it doesn't have to be SSL encrypted, so it can also be a non-SSL virtual server, but you're gonna have to have that HTTP2 keyword on the listen directive, whether or not it is SSL enabled. And the key directive here is gRPC _pass, and it functions just the same as proxy pass that we covered earlier. So you just do a gRPC pass, gRPC : // and then the name of our gRPC server. That can also be an upstream group there, so it doesn't have to be an actual server. You can be an upstream group and have NGINX load balance to that upstream group. You can also do gRPC s : // if you want NGINX to do SSL on the back end. NGINX does not have or does not do active health checks. NGINX has passive health checks built in. Our open source does. So if a server fails, NGINX will retry that request on a different server. It's very common to have active health checks or out-of-band health checks. Sometimes they're called that as well. In this case, NGINX is going to send a probe packet every so often. And in the sample configuration, what we're going to do is configure NGINX to send a probe every 5 seconds to /test.php. And that's the bolded line health _check. And then we're going to check the response with a regex, and the regex is just going to check to make sure that it has the server name and then is alive. And so that is active health checking with NGINX, and it's going to do that every 5 seconds. And if it fails some amount of times, then it's configurable, so you can have it say if it fails 3 times, then take that server offline, or it can be more aggressive if it fails twice or once. So there's a lot of configuration that you can do with this, of course. It's also active health checks is a good way to gracefully bring servers offline. So I can just modify a server that I want to take offline instead of saying it's alive. And for this example, I can say it's dead. And then NGINX will then bring that server offline, stop sending traffic to it. Then I can gracefully take it out of rotation, do maintenance on it, and then change that tag back to is alive and then bring it back into rotation. So it's a good way of doing maintenance on servers as well. Active health checks are exclusive to NGINX Plus. NGINX open source only does passive health checks. Session persistence also very handy if you have a stateful app that maintains session state on the application server itself. So there's a couple different ways to do session persistence. With our open source offering, we do it based on IP hash, so just the client IP address, and the same client IP will always go to the same server. That's not the best way of doing session persistence. Inserting a cookie is a better way to do it, and so we do that with the sticky cookie directive here, and we specify how long the cookie lists for, the domain that it's valid for, the path the cookie is set for, but a few other parameters that you can specify. And so what NGINX is going to do basically is just insert a cookie in there, and then when the client comes back again later on with that cookie, it's going to look at that cookie and then send the client to the same server that it was sent to before. So it's going to maintain persistence that way by inserting a cookie. There's also a sticky learn session persistence with NGINX, where NGINX can then just modify, or rather look at a application server set cookie. So if your application server, for example, sets a PHP session ID or a J session ID, rather than have NGINX insert a new cookie, we can monitor that cookie, and anytime that cookie comes back from the client, we send them to the same server that they came in from. So all forms of session persistence, except for IP hash session persistence, are exclusive to NGINX Plus. Okay, and so we're going to end off with some talking of logging and monitoring before we do a summary and Q&A. So NGINX open source has a built-in Stub status module, and that provides some aggregated statistics. So if you want to enable that module, and it's a good idea to do so, you do a location block, and it can be anything. In this case, I just use basic _status, but you can name it whatever you want to, and then just do the Stub status directive inside of that location block. And now those stats will be enabled when you either use curl or a web browser to go to my site, example.com/basic_status. Then I'll see the actual numbers there. And you'll see the active connections at this moment in time and a number of other different parameters here. NGINX open source will give you about 7 metrics that you can monitor. With NGINX Plus, we have over 40 additional metrics. That's something that we do make exclusive to NGINX Plus, is the additional monitoring. And so with NGINX Plus, you get detailed outputs such as number of 404 errors, number of 500 errors, requests per second, connections per second, number of total requests. So a lot of different metrics are available within NGINX Plus. And so to do that, you enable the NGINX Plus API, which does monitoring as well as some management as well. So you can manage upstream groups and load balancing pools and a few other things with the NGINX Plus API, but we're going to enable it here just for monitoring. So we just do location/API, and then the way to enable the API is API keyword, and then we could do a write equals on as well if we're doing management with the NGINX Plus API to modify upstream servers, and then we do a write equals on. The next few directives here limit access to the API. These directives are also available in our open source offering. It's just basic IP ACL functionality. So we just punch a hole, in this case for 10.0.0, if that's our local network, and then deny everything else so that only our local network can access the stats. Probably not something you want exposed to the public internet, of course. If you want to see our status dashboard and the additional metrics that we have with NGINX Plus in action, just go to demo.nginx.com and you can see the wealth of metrics we make available for our NGINX Plus users. NGINX maintains by default has some very robust and powerful access logs, and you can see a sample of what a default access log with NGINX looks like. We print out a number of different pieces of information, such as the client IP address, what they actually did, was it a GET request, what URL they requested, HTTP1, HTTP2, what browser they were using. So a lot of different information is printed out in the access log. It's highly configurable, so you can put out whatever you want in the access log by using the log format directive. You can even have custom access logs per location, so going back to the request routing earlier, you can have different locations that each have their own access log because they might have different information that you want logged for that particular location. So very, very powerful access logging within NGINX, any NGINX variable. And you go to that URL here in the second bullet point to see all of the NGINX variables available. Any of those variables can be put into the access log. Something to keep in mind as you move to production is you might want to disable the access log because there is a performance hit from using the access log. And in our performance testing that we publish, we always have access log disabled. So something to keep in mind is the trade-off between performance and visibility. All right, so to summarize before we get to the Q&A, it's recommended to use our NGINX mainline branch. That's what we recommend for most deployments. What we actually prefer people to use is our mainline branch. All configurations should go into separate files in the conf.d subfolder of etc nginx with a .conf extension. I usually just use hostname.conf, so www.example.com.conf is the way I keep things organized. You typically don't need to modify nginx.conf directly, and we don't recommend you to use the sites enabled or sites available folder. I always thought that was confusing, and why is there two? So we've just consolidated to a single conf.d folder. Forcing all traffic to SSL improves security, and you can do that with NGINX. You can just redirect all clear text traffic to SSL. That also improves your Google search ranking, so it's good for SEO to SSL encrypt everything. Using Keepalive connections on the back end improves performance, as does SSL Session Caching and HTTP2. So these are things you want to look into as you move towards production with NGINX, is enabling Keepalive connections, SSL Session Caching, and HTTP2. And there's a variety of different monitoring and visibility options with both NGINX and NGINX Plus. All right, that concludes this webinar. And next up is Q&A. Oh, actually, sorry. One thing before we go to the Q&A is a mention of our NGINX conference coming up, October 8th through 11th in Atlanta, Georgia. Atlanta, Georgia is a great city, lots of good live music, lots of good food. You're going to hear from industry experts, both from within NGINX, our developers, our technical staff, as well as people within the NGINX community, how they're using NGINX to solve real-world business problems today. So if you're interested in learning more about NGINX, definitely consider coming to our conference. All the information you need is on nginx.com/nginx.conf. All right, now we can move to our Q&A.
All right, thank you, Faisal. And we have literally gotten to the last minute. I'm just going to mention a couple of quick things that people were asking about the actual, about the actual demo that you used. there's a question here. What does Microsoft use NGINX for? We don't talk about how specific companies use NGINX, but I can mention something that might be relevant, which is that one of the use cases I described is NGINX is a reverse proxy server in front of existing servers. So you'll find NGINX used in all sorts of different environments, even ones that use other web servers as a reverse proxy server, distributing traffic in front of them. Faisal, is there a preferable distribution for running NGINX?
No, not really. I mean, it's just really what you want to use, and we support a bunch of them. So we support Red Hat, we support Ubuntu, Debian. So just whatever you're most comfortable with, just go ahead and use that distro.
Okay, a couple more questions. What would be the case when one needs to configure more servers to serve the same site? Would you balance out by opening more ports? That seems to be the question. It says server balancer by opening more ports. I'm not sure if I can make out what that means.
Yeah, I'm not fully sure. So if you're looking, like you're saying, you want to scale out, have multiple NGINX servers, how do you do that? Different ways you can do that. One way is just to load balance. The load balancer is using DNS, so you just have all of your NGINX servers tied to the host name, and then using DNS round robin that can load balance it. So that's a good way to scale, a nice easy way to do it. So that's what I would recommend if I do understand your question properly.
Okay, great. And then there were a couple of specific questions about the setup, and then we'll have to close off. When talking about the listen directive inside the virtual server context, you didn't mention the meaning of default server after the port number?
Yeah, and I apologize for that. I did mention it. So if you go back to the section where we talked about multiplexing multiple sites on one IP, we did talk about the default server, and what the default server and where it comes in handy is if a user request comes in without a host name specified or a host name that doesn't match any of the existing server names or any of the existing virtual servers we have, that's where the default server comes into play. So it's just kind of the catch-all. What does NGINX do if it doesn't match any of the existing virtual servers it's listening on? The default server is what it's going to select.
All right, you guys, thank you very much for your interest and involvement. We may do a follow-up session with some additional information and a chance for an Ask Me Anything, because there's clearly a lot of questions about NGINX configuration and a lot of good ones. So thank you, and please keep your eyes open for our future webinars, and we appreciate your engagement and involvement today and with NGINX.